Good afternoon. The next project was made by students of electromagnetism. In this video, we are going to talk about the magnetic induction soldering iron. Soldering iron by magnetic induction consists of a magnetic file or a workpiece. It's a coil that shines frequently. It's a tip that serves to weld the thing. The flowing current through the coil generates a changing magnetic fields that induces a falling in the bearing, and due to these electrical resistance losses of the heat energy are generated. In current, this soldering iron we see an inductive heating phenomenon, and we can clearly analyze it to the theory of AC power. In its simplest of form, the AC power consists of two coils of wire wrapped around an iron core. The coil on the left, what is connected to the input source voltage, is cancelling winding or primary winding. The coil on the right is connected to a resistor. It's cancelled secondary winding. The purpose of the iron core is increase the magnetic flux through the coil and provide a medium and which all or most of the field lines that pass through the primary coil as to pass through the secondary coil. Faraday's law states the voltage at the terminals of primary circuits in the magnetic flux through each turn, assuming all the magnetic field lines remain with the iron core. The flow through each turn in the primary is equal to the flow through each turn of the secondary. Given the output falling in terms of the transformation ratio, we can find the Joule effect, which is if the heat generates both electric falling and this directly dependent on the intensity of the falling, the time that is circulating through of the conductor, and the resistance to the is phased of
Mathematical calculation of the transformer. To calculate our transformer, we will use some formulas that help us determine the cable type, number of turns, caliber, etc. We can see the data we use and the constants that are involved in the formulas. First, obtain the core section, multiply side A and side B. Having this information, we will know the power of our transformer with the following formula, which is the core section square. We continue to calculate the power on secondary and primary. In the secondary, we multiply the value of volt 2 by current 2. In the primary, it is to divide the previous result value on transformer efficiency. The area of an inner column, that is the constant of the core, is 1.5 multiplied by squared primary power is calculated. Now, for the number of primary windings will be constant primary windings on the primary squared power. This is not for the winding, it is clear. Then, the previous data having now see if the number of turns to take the primary coil. This will result by multiply the previous voltage 1. The operation is performed for the number of turns or the secondary winding by the voltage multiplied 2 with N2, where N2 is the secondary constant power on 1 squared. With all the above data, it only determines the caliber of the primary winding, where power is divided over H1 voltage. Also, for the caliber of the secondary is the power of 2 on 2 voltage. We can see the calibers we need to use in the project after having mathematical data and continue with the process and the missing and begin assemble materials.
I explain the example process. We will take the measures to transformers plates. The curve measure 3.2 width and 6.0 length. The transversal area is 22.44 square centimeter. The transformers will have a primary coil with receiver 127 volts AC, and this will generate induction for the secondary coil. The primary coil will have 218 levels, and the curve with cable gauge 26. The second coil with cable gauge 18. The transversal will supply 2 volts and 78 amperes to current. We select a soldering iron strip to nickel. It's better for their proprietors. It's resistant to temperature rise, and it's an excellent electric conductive.
Well, to conclude with this project, we could further understand electromagnetism because of a for the relation of it was investigated on the functionality and performance of a soldering iron, and we were able to realize that it must have knowledge of the subject because with the help of the herself could do the calculation as you can see and to see what type of cable had to use to the coil primary and coil secondary.
With the investigation, we were able to know how to up of the soldering iron to testing for welding and soldering a component, and we could give it that if the amperage is less than 13 amperes, why gauge heat up may little tells that his tax is soldered coating component the soldering finally meet and as a tool to perform work with the